So homework was FizzBuzz function version? Okay. So how did that go? Couldn't figure it out? Or could? Couldn't? How did it go in general? Little rough?
I had the problem with like when I was trying to return both strings and integers. But I made it way harder. And it wouldn't let me because they were.
Okay. But you weren't supposed to return, you were supposed to print.
Yeah. Which was the
problem. That was his problem.
Yeah.
Okay. Okay. Got it. So, well, let's look at this today then, right? So let's get rid of all this extraneous crap. All right. So we were supposed to write a function. You can call it whatever you want. Maybe Gen FizzBuzz or something like that. That takes in a minimum and a maximum number, right? And it generates the FizzBuzz output for all the numbers between the minimum and the maximum number. Now remember, previously you had written just not in a function, but you'd written the code that prints out the FizzBuzz numbers for the numbers between 100 and 1,000, right? So I want you to replace the 100 with whatever min is, and the 1,000 with whatever max is, right? But to even get started, we need to write the header for our function. What inputs it's going to need in order to do its job. So, as I advertised last time, our functions will always start with the word static for right now. I'll give you the punchline of that later, but they start with static for right now. All right, and this guy is not actually going to return anything. He is displaying stuff, not returning stuff. So we're going to say void is the return type. All right, and let's call this guy Gen FizzBuzz. Generate FizzBuzz or something like that. And we'll take an int min and an int max for our min and max values. All right, now we want to go ahead and create our loop that goes through all the values between min and max. Okay, so I'm going to start off with a miniature version of this function just so we can see how it works before we dive into the FizzBuzz aspect of it. So we're just going to write a loop that starts I off at min and keeps going until I gets to max. And we're going to print out I each time. Just kind of proving that we can call this function multiple times, going through different ranges of values. Make sense? Okay, and I mentioned it before, but one thing you're going to want to start focusing on as you're working on your homework is don't try to solve the giant problem. Break it down into little tiny steps. Okay, you're definitely going to want to do that for the last part of your homework assignment due Tuesday. Otherwise, it will be an absolute nightmare. It'll probably be a nightmare anyways, but no giggles from that one. Just like now, I'm just starting to piss you off. Perfect. That's exactly where I want to have you. See, the setup is I like it for you to hate me until the end, and then it's like, oh, this was actually useful, and all that stuff that used to take me 10 hours I can now do in 20 minutes. So I'm good now, but I hated him before because my life disappeared. All right, so in any case, let's go ahead and write the loop. For int I is equal to min. We'll keep going as long as I is less than or equal to max, or you can say less than max. I don't really care. So you can go up to including max, or you can go up to including max minus 1. Didn't really make a difference for what I'm going to give you points for. And then I plus plus. We did talk about the plus plus dealie, right? Okay. And we're just going to go ahead and we're going to print out I for right now. So right now, even though the function's called Gen FizzBuzz, it takes in two integers, one called min, one called max. We could have called it elephant and dog. All right. All we're going to do is go through all the numbers between min and max and print them out. All right. So what will the output of this program be right now if I hit play? Nothing. Why? Okay. All programs begin and end with main. And right now, main says do squat. Right? Don't do anything. So I have this untapped resource. I've written this function that if I were to call it, will do something. but I haven't actually called it. So let's go ahead and call it with the numbers 5 through 10, just so it fits on the screen nicely. Okay, so I'm going to go ahead and call it, this guy is a class method. Therefore, I'm going to call him with the name of the class. I kind of advertised that last time. So I'll say hello.genFizzBuzz, and we're going to say 5 and 10. All right, so this should give me all the numbers on the screen between 5 and 10, just printed. So we'll go ahead and run that. Let me expand this a little bit. So there's our 5 to 10 on the screen. If I change this to 52 and 71, now I'll get 52 to 71. All right, so we see that me changing the inputs I'm passing into this function changes the output of the function, because the function is utilizing those inputs to solve a problem. Make sense? All right, so now I just need to embed my FizzBuzz logic into this guy for each value of I. So if I mod 3 is equal to 0 and I mod 5 is equal to 0, I like spacing these a little more than that. Something like that. Then we're going to print out FizzBuzz. Else if, and we talked about the contradictory teaching there last time, where technically I say always use the opening and closing curly braces with the exception of else ifs. Okay, make else ifs work like I'm about to write it, otherwise you're going to have curly brace diarrhea. I did introduce that as an official term, right? Okay, good. Because you'll find it in no books. But it might be on the midterm. It'd be a very strange midterm question, wouldn't it? Briefly describe curly brace diarrhea. All right, so else if I mod 3 is equal to 0. So if it's only evenly divisible by 3, we wouldn't be here if it was evenly divisible by both. Okay, but only if, so if it's not evenly divisible by both, let's check to see if it's just evenly divisible by 3. If it is, this is the fizz. Okay. Else if I mod 5 is equal to 0, this is the buzz, else just print out I. Okay. A couple things I noticed from grading the previous assignment is, well, some people try to convert I into a string. Not that we've learned that at this point. We'll learn that today. But the println function, and we'll learn why at some point soonish. But the println function exists in many different forms. One of the forms knows how to take an integer and print it out. Another form knows how to take a string and print it out. Another one knows how to take a char and print it out. So you do not have to convert an int into a string in order to use println. Pass it an int, it'll print it out. Make sense? All right. So here's my function now. So instead of just going through and generically just printing all the I values out, now I'm going through and I'm checking each I value and either printing FizzBuzz, or just the number. Okay? So here's all my FizzBuzz logic now squeezed into a function that takes min and max, and I'll check all the values between min and max. So we'll just pass it the 52 to 71 here. So there's my FizzBuzz for 52 to 71. I can call the function a second time and pass it 1 to 10. Here, I'll just put a little print statement in here, system.println. We'll just put some asterisks to divide it up. So there's my 1 to 10 FizzBuzz. Make sense? All right, so that was the homework, right? Let's solve all of it. So questions about that? Make more sense now that you saw it? And again, I think I said it last semester as well, extremely common for you to work hard on the assignment at home, either barely get it in a really weird way, or not get it, come to class, see the solution, and be like, oh, it was that easy, something like that, or that looked easier than I thought it was. Okay, very common, so if that's the boat you're in, you're exactly where you should be. Okay, so today I want to talk about strings. All right, so what we're going to do here is we're going to introduce the string class. I like to say that Java is a string-based language. So if we can get something into the format of a string, strings are very malleable, so we can convert them into all sorts of different things. We can work with them a lot if they're, work with them easily if they're in a string format. Okay, so strings in a sentence are a collection of chars. Let's say char primitive types stored between opening and closing double quotes. That's what the string type is. Okay? So examples of strings would be like hello, or elephant, or 4 spaces, or this is the empty string. Empty string is an important construct for us to work with. Very often, if we need to convert something into a string, we'll start with the empty string and concatenate on that something to the empty string. And now it's a string. Okay, so for example, let's go back into our code here. If I have int I, and we'll set I equal to 5, and I say system.out.println I, what's going to print out to the screen? Print out 5, right? No tricks, nothing up my sleeves. Okay, so this is going to print out 5 to the screen. There's our 5. All right, now I'm going to say string s is equal to, we're going to start off by saying I, and it's going to scream at us. Okay, why? I is an integer primitive type, and I'm trying to shove it into a bucket built for holding strings. Not allowed. Java is a strongly typed language. I've gone to Target, I've bought this container. This container was built for holding one of these kinds of dudes, and I'm trying to put something else in there. Not allowed. So if I want to store it inside of a string, it's got to be a string. All right, so a little cheat. I'm going to use have we talked about the concatenation operator? All right, well, let's talk about it real quick. I know we did concatenation last semester. Concatenation, so this is gluing, is that how you spell gluing? Oh, apparently. Gluing multiple things together and ultimately producing a string. It's actually a capital S string. In Java naming convention, typically objects start with a capital letter. So all objects that are built into the language like strings will start with a capital letter. Although when we start writing our own objects pretty soon here, there's no rule that says it has to start with a capital letter. We probably should make them start with a capital letter if you want to follow Java's naming convention, but it's not going to scream at you if you don't. All right, so concatenation is the act of gluing multiple things together and ultimately producing a string. So for example, if I have, and the operator is the plus sign. So this is the concatenation operator when at least one of these sides is a string. Okay, so operators typically have something on both sides. So we have something followed by an operator followed by something. If at least one of those animals on either side is a string, the plus sign will be treated as the concatenation operator. If it's not, the plus sign will be treated as the arithmetic plus operator, addition operator. Okay? So, for example, if I were to say the string hello concatenated with the string world, this would produce for me hello world. Those guys glued together, back to back. If I were to concatenate the empty string with the number 5, this would produce for me the string 5. This is a power tool for us. Leveraging that empty string, the string that is a string but contains 0 chars, to convert non-string, well, let's say convert primitive types into strings. All right, so this is a power tool go-to move for us. Like I said a few minutes ago, having something in Java in the format of a string is very powerful. You can do things with it once it's a string. So being able to so easily get an integer into a string format will benefit us. Okay? Make sense? How concatenation works? All right, so let's look at this a little bit. So again, can't store I directly in S, but I can store the empty string concatenated with I in S. Because I is going to boil down to 5. The empty string concatenated with 5 will boil down to the string 5. Make sense? So now if I'm going to go ahead and print out S. Now when I print these out, you'll see that they both look identical. Visually, we cannot tell the difference between this guy and this guy, right? They look the same. But if I say print out I plus 2 and print out S plus 2, what will my output be? Well, what's I? We want to baby steps. We're going to boil it down. So the variable I will resolve to what value? 5. And what's 5 plus 2? 7. So this line should be a 7, correct? All right. Variable S will boil down to what? The string 5. The string 5. So the string 5 concatenated with, because at least one side is the string, 2 will boil down to what? The string 52. Yep. So there's our 7 and there's our 52. Proving that the second dude is a string. Make sense? So we see the plus operator being used in both circumstances. Same operator, different meanings, different semantics, depending on how it's being used. So as long... I thought it was funny. Is that a frog?
It's a cliff racer.
Cliff racer.
A monster from the game. Yeah.
Oh, Morrowind? Oh. Isn't that an old game?
Yeah.
Is it like making a comeback?
No, I just.
Or you just play old games?
It was my first PC game.
Yeah. No, I get it. I mean, I go back and play some older games. I liked when I played Morrowind for PC. If I remember correctly, there's like a cheat code where you can go into like invincibility mode. Yeah, so I did that. And then you can kill anybody. And then I ended up killing some guy, I guess was a main character in the game, like supposed to be there until the end. And it gave me this error message saying that, the
The line of prophecy is severed.
yeah, something like that, you're living in a corrupt world now where things cannot go on. And I lost interest like that because the God complex wore off when I realized I couldn't complete the game now. They need to, like, I don't know, put little glowing stars above their head or something like that. It says, don't kill me. So I would just go in and just ravage the tavern. Did you play Elder Scrolls Online at all?
I was in the beta.
Okay. Yeah, I played it when it first came out, and I told my wife that I was going to get, my goal was to become a vampire, which I kind of like that idea that you actually had to get bit to become a vampire. So in the end, there ended up being like a big like economy around this. Like you had to pay like a lot of gold to pay somebody to bite you. Okay? And the gold farmer people, they would end up killing off all the naturally occurring vampires so that you couldn't get bit in the wild. You had to get bit by other players, therefore having to buy a whole bunch of gold from them in order to do it. It was a very creepy scenario. So I ended up having gold. I earned the gold myself. I didn't buy it. But then I paid this guy, and we went over to this corner, and he bit me, and my wife was really creeped out by it. It just seemed dirty, is what it came down to. Yeah, right. But then it was really cool afterwards. Inconvenient, but cool. Like I'd be in the middle of a dungeon or something like that, and all of a sudden I would be less effective because I was hungry. I needed to port out of the dungeon and go feed. So I found this nice little area of peasants to feed on. How could you not like that part? But then that got old. I gave up the game.
I didn't get to that part because I couldn't figure out.
But doesn't that sound awesome?
Yes.
Yeah. See. But then once I was a vampire and realized this was as good as it gets, then the game wore off. All right. Man, that was a tangent. We went from, was that a frog noise, to no Morrowind. Oh, have you played Elder Scrolls Online? Let's talk about vampirism. Christian worldview. Vampires are bad. All right, so we see the difference between the arithmetic addition operator and the concatenation operator in terms of use in practice. Make sense? All right, and again, this is going to be a very important go-to power move that you're going to use a lot. You'll use it in our homework assignment tonight. You're going to use it all the time, because you can very conveniently move an int, for example, into a string. Or a char, less conveniently, is say a char into a string. That's not something you necessarily would use all the time, but sometimes we want to build up, convert a string or an int into a string and do something with it. And we'll see some examples of that. All right, so now what we want to do is we want to introduce some of the string methods. All right, so these are, just like for today's class, we wrote our own method to do something. Our objects in our languages come with built-in methods. So we have two different types of variable types in our modern programming languages. And we typically have primitive types, right? That's our byte, short, int, long, float, double, char, boolean. Okay. And then we have object types. Now, a primitive type can do what? What would be the definition of a primitive type? If somebody were to ask you on a quiz at some point, for example. So if I asked you what are the primitive types, it would be that list we just said. What if I asked you what is a primitive type? What would be the definition of a primitive type? Go ahead.
Variable types that go into the language.
And can only hold one value. Yeah, can only hold a value. So primitive types they're not that complex. They're built into the language and they can only hold a value. One value. Okay, very simple. Can't do anything else. They don't get magic tricks. They don't get methods. They can only hold values. So strings are object types. So the definition of an object type may or may not be built into the language. So many objects are built into the language, but we as users can build our own objects. And we're going to start doing that fairly soon. All right, so there's literally an infinite number of objects since we can build them ourselves. But object types allow us to hold 0 or more values, so we are not limited to just holding one thing. We can hold multiple things. And we can also potentially do more through methods. So we can write methods associated with objects so that our objects can now perform additional magic tricks, can do extra things. Make sense? All right, so for example, strings have methods built into them. I'm going to actually write the method headers like the Java documentation shows them. Okay, and we're going to do a halvesy introduction to the class, the static versus non-static today. Just a little foreshadowing. Okay, so one of the methods we have available to us is a method called length. Length returns an int, its name is length, and it takes no parameters. Okay, and this guy returns the number of characters in the, I'm going to call this the calling string. That is the string that called its own length method. Okay, now before we go farther into this, let me show you on the documentation side, because one of the skills we want to get out of here is being able to read programming documentation. All right, and it's going to be very important for us because you're not, no matter how hard you try, going to learn the entire language. Okay? I've been writing Java since literally it was invented, which was in 96, 97, something like that, long time. And I'm probably being aggressive by saying I maybe have seen 20% of the language. There's so much crap, extra fluff, extra objects that do all sorts of specialty things, okay, in the Java, the big scheme of things, Java language, that we only are exposed to the things that we've used to actually solve problems. And if there's some really obscure object that might solve something very helpful, assuming you're going to solve a problem that requires that, great, you'll be exposed to it. But if not, I've never had the opportunity to stumble upon that. All right, so a long time with the language, and I have not seen all of it. Well, technically, I've probably seen all of it, because at some point I've probably scrolled through the list of all classes, really quick. So we're just going to say my eyes absorbed all that and then immediately forgot it. So let me show you in the documentation how to get to this stuff. So I usually start off, and this is proof of long-term Java stuff. I usually go to java.sun.com, even though Sun doesn't even own Java anymore. Oracle bought Sun, but this will redirect to an Oracle page. So I start off by going to java.sun, which is sunmicrosystems.com, and this will take me to some Oracle site. All right, let me make this a little bit bigger here. And then down here under Technologies, I pick Java SE. And then down here under Java Resources, I pick Java APIs, Abstract Programming Interfaces. Okay, and then under Java API specification under Standard Edition, that's the SE Standard Edition. I don't care which of these you pick, just pick the top one. So SE8, for anything we do in here, this will be sufficient because we're mostly talking about core stuff built into the language. With each new version of Java, they add some new stuff, they remove some old stuff, so they call it deprecating. They deprecate old functions and stuff like that. But in the big scheme of things, from learning Java as a core development tool, nothing really changes. You could probably look at the documentation for Java 1.5, and it'll probably work just fine for 99% of the stuff we see in here. But we'll go to Java SE8. Okay, so right now, this is the organization of the Java documentation. So up top, we have our packages. And what we're going to be most interested in here most of the time is a package called java.lang. Okay, this is what's built into the core Java language. This is what we get by default without doing anything else special. Okay, if we don't do any special importing, which we don't know about yet, we get all the crap that's in there. All right, but as we can see here, here's our all classes. So we can see there's a whole lot of stuff in the Java language that exists. Okay, each one of these is an object built into the language. Make sense? There's a lot of stuff there. All right, so I'm going to go to java.lang. This is the core Java language. All right, and we're interested right now in the stuff that's underneath classes. All right, so we can see that it's much more palatable. Here's the classes built into the core Java language. Not bad, right? And specifically right now, we're interested in a class here called string. So click on string. So this gives us the information about the string class. And we're going to talk about some of this other stuff later, but for right now, just forget about the fluff up top. And we're going to come down here and they kind of teach us about strings a little bit. But we're going to look specifically at the documentation and we're going to go past the constructors. We're going to talk about constructors when we start dealing with our own objects and also other objects. Notice that some of these things say deprecated on them, where they've taken away some things that used to exist. Actually, deprecated means we haven't taken it away yet, but be prepared. So you'll get warnings that say this is deprecated, so it will work now, but beware. At some point, your code will break. All right, and then we're going to scroll down here a little bit. We're going to go and find our length method. Okay, and it is alphabetical order. So here is length. So notice it returns an int, its name is length, and it takes no parameters. That's how we read this documentation. All right. Now, notice there is not the word static here. Okay, no word static. Methods come in two flavors from a visual perspective. Some that will say static, some that won't. Okay? We're looking at methods here that do not have static in front of them. So we're going to go ahead and create a slide that's kind of a first pass at talking about the difference. Static versus non-static. We're not going to get too deep into this right now. Static members, okay, where a member can either be a field, a method, or a constructor. Constructors don't even exist. For right now, let's just call them methods. Static methods are owned by the class in which they are defined and must therefore be called using the full name of the class in which they were defined. So if it has the keyword static in front of the method, whether you wrote it there or you're looking at the documentation and somebody else wrote it there, if you see the word static, that means that method is owned by the class itself as opposed to something else. Okay? If you see the word static, that means the way we call that method is using the full name of that class. Make sense? We've already seen that. We said hello dot gen fizzbuzz, right? Why did we do that? Because fizzbuzz, gen fizzbuzz, had static out front. Since it had static out front and it was defined inside of the hello class, we call it using the name of the class, hello.genFizzBuzz. Make sense? Okay, so for right now, that's what static means for us. Static tells us how we call it. Later on, we'll talk about why some methods are static and some other ones are not. Okay, there are differences, but for right now, we just want to be able to call them. Non-static methods, that is methods that do not have the static keyword out front, are owned by instances of the class in which they are defined and must therefore be called by a specific instance of the class in which they were defined. Okay? So which category is that length method? Is it a static or a non-static method? You see static there? Non-static. Okay? How are non-static methods called? They're called using an instance of the class in which the method was defined. Okay? So we're going to come back out here, and then we're going to go here. We're going to create a couple of strings. String s is equal to hello. Now we'll start with that. So I can say s dot length. So I'm not saying string dot length. I'm saying s dot length. S is an individual instance of the string class. Okay? That's even a lie. S is actually a variable that holds an instance of the string class. That's even a lie. When I say string S is equal to hello, what is S? S is a variable. S holds a pointer to a place in memory where an instance of the string class lives. And it is that instance that has the length method. Length methods are owned by instances of the string class in our example here. That make sense? Okay, so I can say s dot length. But can I say hello dot length? Why?
Because S is essentially holding the variable hello.
So the actual instance is the string hello. S is not an instance of the string class. S happens to be a pathway for us to ultimately get to the instance of a string class. The actual instance that we'll find by following the yellow brick road starting with S is the value hello. So hello.length is the same thing as what we set up here, because S is ultimately going to resolve to the value that it points to, which will be the string hello. Make sense? So both of these guys are perfectly legal because the first guy is actually syntactic sugar for the second guy. Now, would we ever actually hard code and say hello.length like this? Probably not, because we would just say hello has 5 characters in it. KK, thanks. Right? We're done. But sometimes we don't know the actual value that lives inside of a variable. So S holds some string. We can look above and see that that string happens to be hello in this case. But in a programmatic situation, we might have a variable that was passed to a function, and we might not know what that variable, what that string was. Okay, so for example, if I come in here and I write a little function down below, static void do something, and this guy takes a string as a parameter, and let's say we want to print out even or odd. Even if S has an even number of characters in it, and odd if it has an odd number of characters in it. So how do I check to see if S has an even number of characters in it? First of all, how many characters are in S? How many characters are in S? The fact that I asked it again probably means 5 is wrong. S dot length, number of characters. S dot length, number of characters. This S and this S have nothing to do with each other. They're in completely different scopes. All right, I could have called this guy Elvis if I wanted to. Okay, I just happen to create a local variable that lives and dies with that method right there. All right, and his name is S. And how many characters are in S? S dot length, number of characters. Because this is a method. Methods are reusable chunks of code that we write once and call multiple times. So I might call this method 10,000 times, and each time I might pass it a different string. So I could in no way guarantee you how many characters are in S, other than telling you generically there are S dot length number of characters in S. Make sense? All right. So I know how to get the number of characters in S. So let's just put that in a variable for right now. So int numchars is equal to s.length. All right, so now I have a variable called numchars. I want to print out even if numchars is an even number, and odd if numchars is an odd number. How would I do that? Probably going to ask some questions, right? Back to how programming languages work. We use memory, we ask questions, and repetition. So in this case, if it has an even number of characters, I'm going to print out even. Otherwise, else, I'm going to print out odd. So how do I ask the question? Is numchars an even number? Okay, and how do I write that? I have s.length stored right here in numchars. So I'm asking, is numchars an even number? How do we check to see if something is evenly divisible by something else? Yep, so numchars mod 2 equal to 0. Okay, so if numchars when divided by 2 has a remainder of 0, that means that 2 went into numchars an even number of times with no remainder. Therefore, it's an even number. So we'll print out system.out.println even. Else, system.out.println odd. Make sense? All right. Is this a class method or an instance method? Is this a static method or a non-static method? Static method. How do you know? Keyword static. Okay, so adding to our definition here a little bit, we're going to say static methods are also known as class methods. Non-static methods are also known as instance methods. Make sense? So when I ask the question, is this a class method or an instance method, we're going to say that this guy is a class method. And then when I say, how do you know? You're going to say because of the word static in the definition. Right now we're looking at method definitions, okay, where we've actually defined the method, determining whether it's a class method or an instance method. Okay, so this is a class method. How do we call class methods? You've told me it's a class method, so it has static out front, which means it's owned by the class. How do we call methods that are owned by the class? You just call them? Okay. Yeah, we're going to be calling methods pretty often. How do we call them?
Last name dot method name.
Yep. Hello dot do something, and we'll go ahead and pass it our variable s. And what should it display for s? What should the output of this program be? How many characters are in s? How many characters are in this version of s? 5. There's 5, an even or an odd number. Don't tax your brains. It's an odd number. So when s gets passed in here into another variable called s, and I store the number of characters in s inside of an integer called numchars, I've stored the number 5 in this particular call to do something. Now we're asking, is 5 evenly divisible by 2? 2 goes into 5 2 times with remainder 1. 1 is not equivalent to 0. So we get into the else, and we'll print out odd. So the output of my code right now should be odd. Because all programs begin and end with main. So what did I do in main? I defined one variable called hello. Then I called do something, which is a class method, passing it s, which ultimately boils down to hello. So that's going to give me the exact same output, right? Because that's what s ultimately resolved to, was the actual instance of the string class that it held, well, that it pointed to, which is called hello. This will still be odd. Similarly, I can say hello dot do something and pass it elephant. That has 8 characters in it. What should that output? Even, because 8 is an even number. So I should get odd then even. Make sense? So the first time through do something, numchars was equal to 5. The second time I called it, numchars was equal to 8. Now, question, based on what we've learned in here so far, did we have to store s.length in numchars? How many times do we use the value numchars? 1 time. Rule of thumb, when do we use variables? Or when should we use variables? Go that route. Whenever we need to use a value more than 1 time. So in this particular case, we would probably just take s.length right here and call it here. And not actually stored in a variable. This says if the number of characters in S when divided by 2 has a remainder of 0, print out this, otherwise print out odd. Make sense? All right. Now, forget about the method definition down here. What if I just showed you the method being called? Okay, so this guy down here doesn't even exist. We don't get to see it. Well, he exists, but you don't get to see the definition. If I showed you this, say on a quiz, and I asked you, is do something a class method or an instance method? What would you say and why? That is not an acceptable answer. Possible answers are yes, it's a class method, or yes, it's an instance method.
Yes, it is
Class method. Okay, why?
because of the static and it's running.
What's static?
It's attached to.
Oh, you mentioned static. What's static? Do you see static there anywhere? What about on this line? Any static? This is all the information I've given you right here. Now we all already know this guy's a class method, right? Okay. But now I'm asking you to tell me why it's a class method from the perspective of us calling the method, not defining it.
Because it's hello dot
Okay, what does that mean?
it's calling it from the class.
The way I'm calling this method is using the name of the class, not an instance. Okay, not an instance of the class. So similarly, if I were to say s.length here, and I asked you to tell me whether length, let's put a semicolon, I asked you to tell me whether length was a class method or an instance method, what would you say? Just by looking at this. If that's all I gave you was that one line, and I said, assuming this is a legal line of code, length must be what? A class method or an instance method? Which of the two? Instance method. Why? Okay, because we're calling it with an instance of an object. And if I only showed you this one line, why would you suspect that S is an instance of an object? Not capitalized, based on what we mentioned today. Typically, class names start with a capital letter, and variable names start with a lowercase letter. Naming convention. Okay? That makes sense? So I might ask you in a quiz or something to look at this from 2 separate sides. I might show you the definition of a function, or even just the header. We don't even need to see all the meat down here, right? All you need to look at is this part right here to tell me whether that's a class method or an instance method. Right there, you know that's a class method because you see the word static there. So at method definition, it's a class method if we see static. It's an instance method if we don't. Up here where we're actually seeing the method being called, it's a class method if it's being called by the class name. It's an instance method if it's being called by an instance name. Make sense? Okay. Very, very, very important skill set. Definitely in our top 5. Because what that skill set lets us do is it lets us read the documentation. So for instance, the next method we're going to look at here is a method called char_at. Class method or instance method? Don't all speak at once. Instance method. Doesn't say static. See, he's had this crap before too. Somebody else has to engage, or otherwise he's going to be the only one who passes the quizzes. He doesn't have to pass the quizzes. He already knows he's going to pass the quizzes. The rest of you are the ones I'm worried about. Okay? I'm just worried about him falling on the hoverboard. How many of you have seen the hoverboard already? We had an 80-year-old lady on it yesterday. So I've been taking it to the cafeteria, sometimes during lunch, pretty often during breakfast time. It's like self-balancing. It's like a Segway without handles. So zipping all around there. So we had an 80-year-old lady riding it. Okay, so this is an instance method. Why? Because we don't have the word static out front. And how do we call instance methods? Not him. And not him. How do we call instance methods? Go ahead.
By just typing the name.
Okay, have I ever done that? Was this guy an instance method, right? And how did I call him? I called him with an instance of the class. All right, so first of all, let me take the do something thing out of here. So we've seen that. What will the output of this program be? I'm trying to trick you, by the way. Why? Good. So this line right here will ultimately boil down to, in this case, 5. And what am I doing with that 5? Nothing. All right. Now, if I go in here and I actually print that out, so I say system.out.println, then I'll get the actual 5. So this code right here will resolve down to a 5. Okay, and that's important because when you're looking at lines of code, you want to ask yourself, what does this do? Well, what does system.out.println do? It prints something. What does it print? It prints whatever is inside of its parameter list here. In this case, what's inside of there? At first glance, you might say, oh, that's a method. Well, it's not. That's a call to a method. And that method's ultimately going to boil down to a value. What kind of value does that method boil down to? The return type for the length method is an int. So that's what that guy will boil down to, is an int. Okay? So this will boil down to an int. Specifically, in this case, it will boil down to the int 5. So after it's resolved that line, that is equivalent to what's being printed. System.out.println 5. Make sense? So it's important that we get into the habit of mentally resolving what happens to things. Because not everything is what it seems. We mentioned that with the Boolean expressions. Some Boolean expressions start looking complex and scary, but at the end of the day, it still boils down to one value of true or false. So one of the skill sets we want to get is resolving things as we're looking at them and not just guessing at what it might be. And many of us are already victims of this, but we've seen it happen from some other students. And when I ask a question, or in even other classes, when a question gets asked, guessing occurs before looking, right? That's very common in programming, where you ask, what does this do? And you start coming up with answers without looking at what it does, or without looking at the actual code, because you have this preconceived notion of what you think it's going to do. There's often a difference between what you think it should do and what it actually does. Okay, and that's part of the gap that we need to close. Because as you guys were working on your homework, you probably had several situations where you wrote code that you thought should do one thing, and in the end it did something else. Okay? And I promise you, 99.99999% of the time, it's going to be your fault, not the language's fault. Okay? It's like, something's wrong with Java. It's busted. I wrote the code that looks identical to yours until you show it to me, and it's not quite identical. It's almost identical, right? Oh, I like the shout out in your homework about the man. Yeah, I was helping him with this assignment the other day. Good example. He thought his code did one thing, and he had one little mistake where he was setting a variable a equal to itself, and when he really meant I equals a. Yeah, so he said, after I got a little help from the man, Dr. Lippman, so that gave you some extra points for that. Just hint, hint for the rest of you. All right, so that's the length method. This will print out 5. All right, char@, what does this guy do? It returns a char. It's called char@. It takes an int index as a parameter, so an integer is a parameter, and this guy returns the char that lives at position index within the calling string. Okay, now this phrase calling string, that is the instance of the string class that called its length method. The instance of the string class that called its char@, method. So as an example here, if I say string s is equal to hello, and then I say string s2 is equal to elephant, right here, this line's going to print out a 5, because 5 is the number of characters that live in the string s that called its length method. In this case, it's the string s2 that called its length method. So it's going to print out an 8. That makes sense? So that's what I mean by the calling string. The instance of the class that called its particular copy of that method. Make sense? All right. So char@. First of all, just to give you a quick look here at what strings ultimately look like. If I have string s is equal to hello, like that, what this is actually going to do is it's going to produce something that looks like that. All right. And this guy is going to be indexed this is bucket 0, this is bucket 1, this is bucket 2, this is bucket 3, this is bucket 4. So even though it has a length of 5, the legal buckets are 0 to 4. That is 0 to its length minus 1. Okay? So if I come in here and I say system.out.println s.char@0, that's going to give me an H. That is the character that lives at bucket 0 of S. If I print out s2 dot char@5, this is bucket 0, 1, 2, 3, 4, 5. It's going to give me the A, because A lives at position 5 in the string s2. No, actually it's H, right? 1, 2, 3, 4, 0, 1, 2. No, it's A. It's A. This is bucket 0. This is bucket 1, bucket 2, bucket 3, bucket 4, bucket 5. All right. There's the H, there's the A. Understand what char at does? All right. And just as a quick example, if I want to spin through every element of a string, I can say for int I is equal to 0, I is less than s dot length. I go less than because I'm going to go from 0 to 4 in this case. There's 5 characters in there. Legal buckets are 0 to 4. That's why I say less than s dot length. I plus plus system.out.println s dot char at I. So this will print out HELLO, 1 character per line. Make sense? So now we've adapted our for loops, which just take an integer on a voyage between 2 ranges typically, so min to max for our homework today. Now we're saying go from 0 to length minus 1, and what am I going to do with that variable each time? I'm going to pass it into the char at method to extract an individual char from a string. Make sense? All right. So that's the char at method. Next method. We have index of. An index of is going to return an int. It's called index of, and it's going to take a char as a parameter. This returns the first, I'm going to capitalize that, the first occurrence of the given char, so in this case C, the given char in the calling string. Or -1 if the given char was not found. Make sense? Okay. Power tool, pro tip, this -1 thing, very important. We can use that to search a string for a particular char, and if we get a -1, that means it was not found. Make sense? So for instance, if I come in here and I say system.out.println s dot index of h, I'm going to get a 0. The first place it finds an h is at bucket 0. If I say s dot index of L, 0, 1, 2, I'll get a 2 because that was the first place it found the L, even though L's there twice. If I say Z, I'll get a -1. Z is not found in the string hello. Okay, so there's our -1 there. That's our power tool with that guy. Otherwise, it helps us find the location of stuff. And as a quick hint for your homework assignment, I'm just going to randomly throw a plus sign in the middle there for no particular reason. And I'll search for a plus sign. And it gives me the position in that string where that plus sign lives. May or may not be helpful for you.
Is there any way to look for multiple things?
Yeah, you can look multiple lines. So look for the plus sign once, and then look for the H on the next line. Now, do you mean individual symbols or like
So like that they'd be in the order.
like a certain order?
Like then if you did like plus and then minus, even if the minus is in one.
For instance, if you wanted to search for hell, the word hell, it's a Christian worldview, I think, right? Count it. Okay. If I wanted to search for the word hell in the string hello, I'd get 0. Okay, but notice I'm passing it a string, not a char. This is actually a second version of the index of method that takes a string as a parameter. So this will also give me a 0. Because HELL is first found there. Make sense? But if I say HEO, for example, I get a -1. Those 3 characters in that order are not found in there. Go ahead.
But could you do like H and then the or sign and then an E so that like, or a W so that see if there's an H or a W?
Well, not in a single call to this, but you would say if s dot index of H is not equal to -1, or s dot index of Z is not equal to -1, then do something else. You'd have to string those little pieces together. Okay, because each one of those is going to return an int, and then you have to create a Boolean expression from that int. So that's why we're going to check to see if it's equal to -1, for example, that kind of stuff.
If you're trying to find the index of like E and elephant, would it just give you the first instance, or would it give you both instances?
It always returns the first instance.
Just the first instance.
So this would, for elephant, s2.index of E would give us a 0.
Okay.
Yep, not a 2.
Is there a way to get the second instance?
Not necessarily the second instance, but there is a way to get the last instance of something. Okay, but that actually is an interesting question you asked, because let me show you our next helper function. That's index of. Then we have one that returns a string called substring. One of these takes in an int start pos, and this returns a new string that is the calling string starting at position start pos and going to the end. There's a second version of this substring that takes in an int start pos and an int end pos that returns a new string that is the calling string starting at position start pos and ending at position end pos -1. So this allows us to extract parts of a string. So this kind of goes hand in hand with what you just asked. So let me show you this. So if you want to get that second E, if I say system.out.println, well here, let's say, let's just do this. Int pos of first E is equal to s2.index of E. That's going to give us our 0, right? Okay, then I'm going to say string temp is equal to s2.substring pos of first E plus 1. Give me everything from that point forward. So let me just print out temp here. We'll see it's everything but that first E. Okay, so, ooh, hello. So there's the elephant with the first E missing. Okay, so I got a substring from S2 by saying give me all the characters starting at position 0 plus 1, so starting at position 1, all the way to the end of that string. So I got everything from position 1 all the way to the end of elephant, but not including bucket 0. And I stored that inside of temp. So S2 is still elephant. I have not damaged the original contents of S2. I've just stored a version of a cut down version of S2 inside of temp. Okay, so now if I call pos of first index E again, now I'm going to get bucket 1 because the first occurrence of E in this guy is that bucket 1. Make sense? And then I could do the whole temp thing again and print it out again. I could do these two things and I'd get an even more cut down version of elephant with the first 2 E's removed. Row. Those 2. Oh, sorry. It's not S2, it's temp. Temp is my cut down version, so I need to say temp dot index of E to get that bucket 1. Store that in pos of first E, then I can get a substring of S2 giving me everything but. So there's the oh, why did that give me the E still there? Look what I called the substring on. Called it on S2, not on temp. So I didn't whittle it down even farther. S2, the position of E is 1. I'm sorry, temp, the position of E is 1. So if I take S2 starting at bucket 1 to the end, I get E5. So I'll change this to temp, and now we'll get a cut down version. Make sense? Okay, finally, I can say something like system.out.println. Let's do S2.substring, and we're going to do begin index, woo, not subsequence, sorry. And let's go from bucket 3 to bucket 6. All right, so I'm going to get the substring from S2 starting at position 3, going all the way up to, but not including position 6. All the way up to, but not including position 6. So I'll get 3 through 5 inclusive. 3 through 5 inclusive should give me just like a center portion of elephant. Make sense? So now I'm able to manipulate strings and extract pieces of them. I'm also able to search strings for the location of individual chars. I'm also able to extract an individual char from a string at a particular place. I'm also able to look at the length of a string. Make sense? So we have several different tools as well as concatenation. I'm able to build strings out of things. So take a look at your homework assignment due Tuesday. The first several questions. Go ahead.
For the homework, is it do you want those characters to be printed out in order as they appear in the string, or is it okay just like depending on what method you use, it would be easier to just if it was out of order.
Which?
So you had elephant, you were looking for only the vowels, and you searched for A first, and then you searched for E next.
Oh, I get what you're saying. In that particular case, I don't care.
Okay.
Yeah, you could just print them out in well, actually, hold on. No. I don't say print it out. Don't I say create a new string with all the vowels removed? Or is it print out all the
It
vowels?
says print all the vowels contained in that string, 1 character per line.
Then I don't care the order on that one. Yeah, but for some reason, I think one of them might be, or maybe it's a future assignment, might be taking a string, return a new string with the vowels removed. Yeah, so if it just says print the vowels from there, I don't care what order they're in. All right, I'll see everybody on Monday.